Hi, I'm Els van der Roest. Welcome to this lecture on integrated energy systems. The goal of this video is to show you some examples of how a heat system can be integrated into a larger multi-energy system. We will look at what a multi-energy system is and how we can integrate heat storage into these systems. Then we will look at some of the benefits of heat storage in multi-energy systems, especially to reduce pressure on the electricity grid. So far in this course, you have been learning how sustainable heating and cooling systems work, and you will soon start with your own design. As an inspiration, I will present to you a case where the heat storage system is part of a larger energy supply and demand system, also called a multi-energy system. In our future energy system, heat is an important player, but certainly together with other energy carriers, such as electricity and hydrogen. In a multi-energy system, different energy consumption sectors are considered, and power to X is an important element. As in our future energy system, electricity from wind and solar PV will be the main energy source. The different consumption sectors are coupled via power to heat and power to hydrogen, as shown in this picture. Other options are power to liquid or other fuels. In this lecture, we will consider a neighborhood with all its different energy demands. Heating is important, but electricity and mobility are included as well. Important in this concept is conversion, so power to X and storage. The case I present to you today is based on developments in the municipality of Nieuwegein in the Netherlands, where a 10 megawatt peak solar park is installed. Because the amount of renewable capacity is increasing rapidly, as well as electrification, the electricity grid in the Netherlands is congested. The red and orange spots on the map show where it is not possible anymore to build a new solar or wind installation. A possible solution here could be to convert part of the capacity from newly installed solar or wind to hydrogen and heat. This creates more room on the electricity grid to facilitate a larger share of renewable capacity. So, what we will look at here is how to connect supply and demand. The multi-energy system for Nieuwegein is calculated with a model including electricity distribution, hydrogen production and storage, power to heat and heat storage, a fuel cell to convert hydrogen back to electricity and heat, a connection with PV systems on houses and a battery, and even an option for hydrogen use in houses. In this system, the heat storage has a very important role. And here we have chosen especially for a high temperature ADA system. I will now explain you why. In a low temperature ADA system, heat is delivered between 15 and 18 degrees to a building, which means you will always need a heat pump to increase the temperature to the desired level. With a high temperature ADA system, it works the other way around. The heat pump is used in summer here to produce heat at a higher temperature, which is stored in the subsurface. In the winter period, this heat can be used directly by buildings without the need for a heat pump. Here you see the effect of a high temperature ADA system, represented by the power to X scenario with the red line, versus an all-electric system with individual heat pumps. Because the high temperature ADA system delivers heat in winter via a district heating network, the houses need less power, even at very cold days. In an all-electric neighborhood, the electricity peak would be much higher and will exceed the existing capacity of the electricity grid. In summer, there's the opposite effect. In an all-electric scenario, the solar panels deliver most of their capacity back to the grid, thereby again exceeding the grid capacity. On the other hand, the power to X system with both a heat pump and an electrolyzer that convert the solar peak power to heat and hydrogen lower the production peak of the solar panels, which lowers the pressure on the electricity grid. How does the high temperature ADA system function? The graph clearly shows how heat demand and heat supply are decoupled over time. In terms of storage efficiency, 60 to 80% efficiency can be reached depending on, for example, the heat storage temperature. Here an example is shown of a very high storage temperature of 90 degrees Celsius. Over time, you see that the system will get more efficient, just as low temperature ADA systems. I hope you have enjoyed this sidestep to a broader system perspective. what I would like you to remember is that ADAS or high temperature ADAS can be a valuable part of a multi-energy system. Secondly, power to heat as part of a high temperature ADAS system can help to reduce pressure on the electricity grid in both summer and winter. So, when you start designing your own ADAS system, try to zoom out and think about how your system would fit into the larger energy system.